Here we show the PEL Dropwatching system used with the Marco printhead and controller. PEL's Dropwatcher can be used with both Nordson PicoPulse and Marco systems. We show an example of jetting IPA, a fluid with a very low viscosity, so don't worry about the satellites you can see here. Our aim is to show what effect the valve's closing voltage has on the drop being ejected. We start at a relatively low voltage and see very small drops that are nice and uniform. We then gradually increase the closing voltage, effectively the force seen on the drop as it is ejected, and watch what that does to the drop shape and structure. At this point we start to see that the drop is ejected with such a high velocity that the head of the drop is inverted by air resistance as it travels through the few millimeters air gap. It is a rather beautiful shape, but probably not something you would want in any industrial application. We now start to push the voltage well past the useful range, and we can see very interesting but quite useless drop shapes. We now return the voltage to a much more usable 220 volts and see repeatable drop formation. These Dropwatcher videos show many hundreds of drops. So the fact that all frames are so similar shows that the process is working extremely well and repeatably. In this section we ramp up the pressure applied to the fluid. In the case of IPA there is actually no need to apply pressure at all, but the purpose here is to show what pressure does to the drops ejected. With a low viscosity fluid, while the valve is open, the additional pressure will drive the fluid through the nozzle. This will result in a longer sausage-like shape. Then when the valve closes again, that slamming force may, if the voltage is high, result in a somewhat explosive appearance to the back end of the drop. We will also move the printhead up to show what the ejected fluid looks like in flight. It is somewhat surprising that the shapes seen are so similar drop to drop, but that is because the forces applied on the fluid are so well controlled by the head. The shape seen can be the result of tiny imperfections or fluid accumulation around the nozzle. In practice, we will always want to apply the ideal waveform to the fluid to create the optimal drop ejection.